The assignment for today is 250A, which would be 45 to 65 odd. The first section for today, oh wow, we're sorry to interrupt. The first section for today is similar to what we did yesterday, but it's much more complicated. Same idea, it's just much more complicated. The patterns are exactly the same. The numbers are just a lot harder to deal with. So we'll start with 45. 33x squared minus 2x plus 15. I separate these, and then I have to pull out the 33. I don't want to, because it's going to make the problem kind of nasty. But you have to pull it out. You cannot complete the square, at least I didn't teach you how, and I could figure it out, but you don't want to complete the square with the leading coefficient. So we pull out 33, and I get 33 times the quantity x squared minus, but 33 doesn't go into 2. So it's 2 divided by 33. So 2 over 33, and then x, we leave a space, and that plus, is it a minus 15? Sorry, I can't see. Plus 15 stays on the outside. Does everybody understand why we've done that? Again, we're converting our original graph in standard form into a graph in vertex form, despite what Cynthia says. No, general form, that there's no such thing as a general form equation. Anyway, Cynthia. Okay. Now we need to complete the square. So the factor would be x minus half of 2 over 33. How do you cut a fraction in half? You either cut the top in half if it's even, but if the top is not even, then you double the bottom. So in this case, the top is even, so I just divide the top by 2, which would be 1 over 33. But if the top is not even, then you double the bottom. So 1 over 33. So what would I need in this place for that quadratic to factor as a perfect square? 1 over 33 squared. What is 33 squared? $1089. So plus 1089. Oh, 1 over. Sorry, 1 over 1089. Okay. Now, it's not really a 1 over 1089. It's 33 times that, and let's be a little bit smart. What is 33 times 1 over 1089? 1 over 33. Because this is just 1 over 33 squared. So if I take 1 over 33 squared and I multiply it by 33, so that was kind of nice. That didn't take too much thinking. Oh, thank you. We need to subtract. Glad somebody's paying attention. So on the inside, I added that number, which is really just 1 over 33. So to compensate and make sure I don't change the equation, I need to subtract it off. When I put this in its place, the graph shifted up 1/33 of a unit. Not very much, just a little bit. So to pull the graph back down to where it was originally, I need to compensate by subtracting 1 over 33. No, I don't know what that is. So 494 over 33. So there's a 33 out front, and then 494 over 33. And the question asks, find the vertex of the parabola. So where is the vertex? This tells me to move right 1 over 33, and this tells me to go up, so the point would be 1 over 33, comma 494 over 33. Okay, does that make sense? Yes, let's take a look at 49. I live to serve. I don't serve A's. Okay, 49. So I need to pull out negative 2/5 and x squared something something plus 2. How do you take a negative 2/5 out of a positive 3/7? Well, I'm going to have a negative, certainly. I need to divide by 2/5, which is really just multiplying by, nope, you flipped the wrong one, multiplying by 5 over 2. So there are a couple ways to do it. One is you could just use your calculator and say, let's take the fraction 3/7, 3/7, and I'm going to divide it by negative 2/5, and then just ask for the fraction form. Or you understand that dividing by 2/5 is really just multiplying by 5/2, so you times the top by 5 and the bottom by 2, which gives you negative 15/14. So negative 15 over 14x, and then I need the perfect square. Mason, you all right? All right, so I have 2/7, and I want to pull out, so I have 3/7. I want to pull out a negative 2/5. So if I had a 6 and I wanted to pull out a 3, I would just do 6 divided by 3 is 2, and this number would turn into a 2. So whatever you pull out, you just divide. So that original 3/7 is going to be divided by negative 2/5. So divide by negative 2/5. You can just plug that in your calculator if you want, like that. Or the rule with dividing fractions is you just flip and multiply the second one. So I turn this into a multiplication and make that 5 over negative 2, and that gives me 15 over 14, but now it's negative. So whether you perform the math in your head or use your calculator, I don't care. All right. So negative 2 over 5 times, what is half of negative 15/14? Negative 15/28. Again, you either cut the top in half or you double the bottom. In this case, the top is odd, so we double the bottom. And when I square that, what's going to go there? 225 over 196. Oh, it's 28, sorry. I squared the wrong one. Sorry, I squared 14. What is it? 784. But it's not really 225 over 784. It's negative 2/5 of that. So this influences that. So really, negative 2/5 times 225 over 784, this is not going to be a nice number, is negative 45 over 392. What do I do with that number? So I should put my 2, and then what? Plus 45 over 392. Why did I add it? Right. This number is always positive, but it's hiding underneath a negative number, so the actual change was a subtraction. I took the original graph, and by completing the square, I shifted it down, not very much, 45, 390 seconds. So to compensate, I need to add that back on, which is 829 over 392. So where is the vertex? Right 15 over 28, and then up 829 over 392. Is that making sense? Would you like to do a decimal problem? What does the answer say? Does the answer give it in decimals or fractions? Is that in fraction form? The answer is in decimal form? It's in fraction? Okay. So look at 51. 51 starts in decimal form, so I would assume the answer would be in decimal form. Okay. I need to pull out negative 0.002. So negative 0.002, and then x squared plus. How do you take out negative 0.002 from negative 0.3? Divide them. Would we expect the 0.3 to get bigger or smaller? A lot bigger. How many 0.002s are there in 0.3? A lot. There are a lot of them. In fact, exactly, there are 150 of them. So this is 150x. This problem is not going to be so bad. So I need to complete the square. This would be x plus 75, and 75 squared is 5625. But it's not really 5625. It's that times negative 0.002. So multiply that by negative 0.002. And I get negative 11 and a quarter. So by adding the 5625, I have dropped the graph 11.25 units. To compensate, I need to go back up 11.25. So I take the original constant, which was 1.7, and add 11.25, and I end up with 12.95. So the vertex is now negative 75, 12.95. Okay? What's up? So this is negative because anytime you have x plus, that is a horizontal shift in the left direction because the x translations are backwards. Rutland, do you get the 150? Divide. You divide. There. This says how many 0.002s are there in 0.3? There are 150 of them. You divide. When you pull this out, you divide both of them by 0.002. That one turns into a 1, and that one turned into a 150. Okay? All right, next section. Number 55. This says, hold on, let me move that over a little bit. The instructions say, find the quadratic function that has the given vertex and goes through the given point. So we have our choice between, we could use the standard form equation or we could use the vertex equation. They'll both work. Which one do you prefer? The vertex? I'll show you both and you decide. The vertex equation is a times x minus h squared plus k. For number 55, do I know any of those values? I know that h is negative 1 and k is 4. So right off the bat, I can say a times x, what would it be? Plus 1 squared plus k. Or sorry, which is 4. Plus 4. Okay? How many equations, how many quadratic equations are there that fit that definition? How many equations have a vertex at negative 1, 4? An infinite number. Right? The ones that open up, there are an infinite of those, and the ones that open down, there are an infinite number of those. So we need to find the only A that will hit the point 0, 2. They told us. Put 0 in for x and 2 in for, not A, to make it equal to, so the equation is y equals all of that. So now we just plug in the x and the y that we know and solve for A, which ends up not being tough at all. So I plug 2 in here. 2 equals A times plug 0 in here. 0 plus 1 is 1 squared plus 4. How do I solve for A? Subtract the 4. So negative 2 equals A times 1 squared is 1. So in that case, A is negative 2. So you're right, Casey. It needed to be negative. Did I just say that? Okay. I think the ceiling is not going to fall. So my final result is negative 2 times x plus 1 squared plus 4. That's one way to do it. Now, you might forget that. Let me show you the other way to do it. And it's going to be a little bit more of a headache, but sometimes you get stuck on a test and you have to work things the long way because it's the only way you can figure out. So we want to create an ax squared plus bx plus c. What do I know about this? If I knew what the roots were, it would be really easy. Standard form equations are created by taking the roots and turning them into factors and multiplying them together. Do I know the roots? Well, actually, I do. I know one of them. Oh, no, that's the y-intercept. Never mind. Sorry, I was looking at number 58. Never mind. If you know the roots, it's easy. But I don't know the roots. Let me show you what we do know. I know that at negative 1, positive 4, that is the vertex, and the graph also hits 0, 2. It hits right here. Can I guarantee any other points? On the other side, across that axis of symmetry, I know that the graph also hits which point, Jake? So if that's the vertex and it hits there, is it a happy parabola or a sad parabola? It's sad. So it must be shaped like that. And because parabolas are symmetric, I know, so at negative 2, 2, that's also one of the points. So I know 3 points. I know the vertex and 2 others. I can find the standard form equation by using my stat. So I know negative 2, negative 1, and 0 for my x's. The y values would be 2, 4, and 2. And then I just ask the calculator, what is the quadratic equation? Negative 2x squared minus 4x plus 2. But I now have to take that and complete the square to find the vertex form. So you pick 3 points, you put in 3 x's, and you put in 3 y's into stat. And then you push stat again and you go to calc and just ask it. Yeah, you have to have your calculator out. So I can come help you do that. So there are usually ways to find answers through the back door. That took a lot more work, but it would work if you understand how to do the complete the square trick. And technically, I did find the quadratic equation. It's just not the form they wanted. So, all work. Good luck.